Hello everyone. Now we are seeing an experiment called Morse test. The aim of this experiment is to conduct Morse test on given multi-cylinder petrol or diesel engine in order to determine the indicated power developed in each cylinder of the engine and to determine the frictional power. The operators used here are, it should be a multi-cylinder engine, whether it is a petrol or diesel engine, or it may have a 3-cylinder or 4-cylinder. Here in this experiment we are considering a 4-cylinder engine, and next we need to have a dynamometer for various load conditions or loading arrangements. The procedure of this experiment is as follows. The engine need to run at required speed and the torque is measured in terms of a Newton meter. Then the cylinder is cut out by shorting the spark plug in case of petrol engine, and you need to stop the fuel supply to the injectors in case of diesel engine. Once the cutout has been done, you can see the fluctuation with respect to speeds. The speed is going to be reduced because of loss of power with respect to cutout in cylinders, and this time the torque need to be measured again once the speed has reached its critical or original value. Then the value of indicated power is measured for all the cylinders. In this method, the BP of whole engine first to be measured at certain speed and load with the help of a dynamometer. Then the output is measured by keeping the speed constant. The difference in output of measure of indicated power with respect to disconnecting cylinders can be noticed. Thus, for each cylinder, the IP is obtained and then is added together to find the total indicated power of the engine. Now you can see the terminologies used for the calculation purpose. BP is brake power, IP is indicated power, and FP is frictional power. Let FP of cylinder 1, 2, 3, 4, that is for all the 4 cylinders, will be named as F1, F2, F3, F4. The total of FP is the sum of individual frictional powers. Similarly, it is followed for IP as well. The indicated power equals I1, I2, I3, I4 for all the 4 cylinders. Then we know the relation between BP, IP and FP, that is BP equals total IP minus total FP. So it can be written in terms of equation number 1. When cylinder 1 is cut off, the first cylinder is cut off, the BP developed by the remaining 3 cylinders can be written as B1 equal to, instead of I1 I have written as 0 because first cylinder cutoff takes place, there is no power developed inside the cylinder 1, there is no indicated power with respect to cylinder 1, so it has been termed as 0. Then other I2, I3, I4 will be same, whereas the frictional power terms is going to remain same because even the first cylinder cutoff takes place, there is no power also with respect to first cylinder, but there will be a frictional losses due to the movement of piston. So the F1, F2, F3, F4 is going to remain constant. Subtracting equation number 2 minus 1, that is B minus B1, will be giving I1. So that is IP1 or I1 is nothing but B minus B1. Here B stands for the total brake power where all the 4 cylinders are in working condition. B1 stands for the brake power when only the 3 cylinders except the cutoff one, whatever the other 3 cylinders are working, that is to be considered as B1. So similarly, you can find out the IP of second cylinder by cutting off the second cylinder, then I3, I4 like that. So all individual add-ups of the indicated terms is considered to be the total IP of engine. And finally, the frictional power can be termed as the frictional power Fp equals Ip minus Bp. Hello everyone. So now we are going to conduct a Morse test on multi-cylinder diesel engine. So one of the main factor is to conduct the Morse test, the engine should be always a multi-cylinder engine. If it is a single cylinder engine, we cannot perform the Morse test on that. So Morse test is always applicable only for multi-cylinder engine, whether it is petrol engine or diesel engine. It should be a multi-cylinder engine. The aim of conducting this experiment is to find out or to determine the Fp and Ip, that is frictional power and indicated power. So here you can see here, this is a 4-cylinder diesel engine. Of course it is a multi-cylinder engine. There are 4 injectors you can notice. So from that you can come to conclusion that it is a 4-cylinder engine. It is a mechanical injectors what we are using for this experiment. Okay, so for Morse experiment we are focusing on 2 parameters. One is the load and another one is the speed. So here you can see here the test rig that is common for all the engines almost, and this is called as the hydraulic dynamometer. Hydraulic dynamometer is used for loading purpose in multi-cylinder engine. So where you can increase or decrease the load accordingly by rotating the wheel of the hydraulic dynamometer, and you can see the same thing with respect to speed and load here on the mechanical test rig. Okay. So to carry out the experiment, first what we are doing is we are going to run all the 4 cylinders together without cutoff. First you find out BP, that is called as total brake power. Then afterwards what we should do is to cut off the 1 cylinder. Then again we need to find out BP, then cut off the 2nd cylinder, then 3rd cylinder and 4th cylinder, like that. That make sure that once you are cutting off the 1 cylinder, other 3 cylinders should be working, otherwise the engine will not start. So once you can cut off the cylinder, you can notice the fluctuations with respect to speed. Then you should bring back the speed to the original position by decreasing the load from hydraulic dynamometer. Okay, that is what we are going to see now. We will be starting the experiment. Just take a look. So like that how we are going to conduct the Morse text experiment. The ultimate aim or objective is going to find out the frictional power or indicated power. Okay. So once you know the BP, then you can find out the other powers from the relationship. We don't know. We know that IP is equal to BP plus FP. So from that you can always